Alright guys, welcome back to the Blender tutorial series. This is the second episode in the series, second workshop, and we're going to be reviewing some intermediate Blender um, techniques and some intermediate stuff you can do in Blender. Mainly I'm just kind of going through the tools that I use on a regular basis. So for today, I have it set out to go that we're going to cover subdivisions, um, array modifiers, Boolean modifiers, mirror modifiers, and just the general modifier stack and how that works. And then we're also going to go into UV unwrapping and some texturing stuff. And if we have time, we're going to go into a little bit more of the advanced materials. Okay, so unlike other lectures or other workshops, I don't have anything specific that I'm trying to build today. So I'm just going to go and hit every point on my list and just kind of show you guys um, the things that I want to talk about. Let me go ahead and turn on my screencast keys. There we go. Okay, so I'm just going to go ahead and delete everything here and then add a cube back in. And we're going to talk about this tab over here, this modifiers tab. And you can see there's nothing here right now, but there's a bunch of options of stuff we can add. So essentially, I'm just going to go through a couple of the most useful ones that I use. Most of these I don't ever use at all. I'm sure they're useful, but in my traditional game asset pipeline, I'll almost never use them. Um, so the first one that I'll go over is the subdivision service. Now, before we go into this, we have to understand what subdividing is. So if we go into edit mode on our cube here, and if I select everything and hit W, W is kind of like a quick access menu for a lot of stuff that edits like the vertexes and edges and stuff. Um, there's a thing here called subdivide, and I can click on that, and it will subdivide all of the selected faces into 4 faces. Now, I can change this to be more faces through the number of cuts, and I can, change some stuff about this, but you don't really ever use this. But let's just go just into the 4 faces. So here, obviously, this gave us more actual like resolution and more vertexes or vertices. So that's what I say resolution. I mean, it gave us more vertices to work with, but it didn't actually like do anything smoothing. Now in here, you can see there actually is a smoothing value. So you can do it this way, but it's not the best. You can smooth through this, but it's not the recommended way to do it, and you'll see why in a minute. Um, so if we wanted to like, maybe add resolution to this, but also smooth it and make it into like a sphere shape, right? Um, then we're going to Control Z out of that. We're going to add a modifier, and it's called a subdivision surface modifier. So this modifier is really cool because as you can see, nothing has actually happened to the object yet, right? It looks different, but we still have our actual object here, right? So if you go back into object mode, it looks way different. Um, but you can see we can still move around our vertices, right? We have this option to edit stuff almost before the modifier is applied, and then this is after the modifier is applied. Um, So what this modifier does is it subdivides. You can kind of see the resemblance of each face on the cube, and then it also kind of smooths it all over. Now, um, you have 2 options over here in the subdivision modifier, the viewport and the render. The render only matters if you're actually going to render out an image. Um, if you're actually going to like render out an image and make a cinematic or something like that, that you're actually rendering something in Blender and not just making something for a game. So this doesn't matter for you if you're just making a game asset. But here in the viewport, you can see when you increase it, you can see what it does, right? So it gives you more resolution and smooths it over more, right? And you can go all the way back out to 0. So 0 is just your cube, no splits, no smoothing, and then you have different levels of smoothing for each one. Okay, so that's one modifier. And you'll notice that I can still edit this, right? Because our object hasn't actually changed yet. Our physical object in 3D space has not changed yet. If we want it to change, we go into object mode. We click this little drop down here and hit apply. And this applies the modifier. And now you can see we actually have physically changed our cube to become this spherical object. So that is the subdivision surface modifier, and that's a really useful modifier because, like, if you wanted to, I don't know, let me just make something real quick. Have like a model here, and you wanted to, I don't know what this is, I just made something random, and you wanted to kind of make this look not as low poly and not as like cartoony, right? You could go ahead and give it a subdivision surface, ramp this up a bit, but now you can see if you add a loop cut, like an edge cut here, right? You can kind of force things to be, like if I want this to be a flat surface here, I can kind of force that to be flat. Now it's still circular, but if I add a loop cut here and slide it this way, it'll kind of, push this over to the edge a little bit. And that's because the subdivision surface modifier acts specifically on your faces. So we've just added a face here that's very small. So um, I don't know how to explain it very well, but like this small face here kind of acts as a barrier so that this whole corner doesn't get cut off, if that makes any sense. So you can go around and you can play around with this stuff. So a lot of times, you can like flesh out the structure of a model, um, and then, once you're ready to kind of make it a higher resolution model, this is a good way to start doing that. It's not the most sustainable way to do that, but this can give you a good like preview of what it might look like. And then also usually when you're using a subdivision surface modifier, um, if you were looking for a higher resolution object, something that looks more realistic than what I usually do for my like toon style games, you would object here, hit shade smooth, and this just kind of gets rid of all the lines and creases. It doesn't actually increase the polygon count on your model. Like you can see, I'm not sure where it is in 2.8. Okay, well, we used to be able to see the actual amount of vertices down here. Yeah, I'm not sure where that is. But in previous versions of Blender, it was down here where you could see, it's got 100 vertices or whatever, right? And, if even when we like apply this modifier, right, to make it an actual mesh, because before it wasn't actually a mesh, it was the outlined object that was not smoothed out. So like before, the object we had still look like this, right? And this modifier gives us a preview once we apply the modifier. And by the way, you can only apply modifiers in object mode, so you have to go back into object mode to do that. Now we've got the higher resolution version of the mesh, and we can shade it as flat, which is the opposite of smooth. It brings these creases back. But once you shade it as smooth, it gets rid of all this without actually adding any resolution to it. So that's really helpful if you're trying to make a higher resolution object. Again, I don't know what this is, but you can see like, these might be the kind of edges that you want to have if you're modeling like a sports car or something like that. You can have edges like this, and it makes really nice, crisp, clean edges. Anyway, um, okay, so that's the subdivision surface modifier. So let's go back to our cube to demonstrate an array modifier. Array modifiers are really good for any kind of abstract art, and you'll see why in a second. If I just click on the array modifier, we seem to have lengthened our cube, but we didn't actually. We actually just made two cubes, and you can see, you know, this array modifier duplicates our object and applies an offset to the duplicated version. So here's our offset. This is relative, so it's, this is going to be depending on the size. So like even if I scale this up in edit mode, it's not going to matter. It's not like it's only going a foot to the right each time. Um, it's relative to the size of the original object. But I can play around with this and make an offset, and then I can go ahead and add to the count, right? And it will apply that offset each time. So if I set these all to 0 and then move this back to 1.1, let me go to 10. So this is making 10 objects, each of which are offset by, you know, 110% essentially, so that there's a little gap in between it, because if you offset just by 100%, there's no gap. So let's go 1.1, and yeah, that's how the array modifier works. Now, you can access a thing called the modifier stack, right? So if you click on this little button over here, you can see you can actually drag all this stuff around. And it kind of asks the question of, okay, well, what if we want to add another modifier? So let's do that. Let's add another modifier, right? So now we can kind of see if we minimize these, that it's a stack of modifiers, right? And the stack always works from top to bottom. So here's our first array modifier that's going 1.1 on the x. So now let's take this, go not on the x, but let's go 1.1 on the y, right? So essentially what it's doing is it's computing this modifier and saying, okay, it's computing this modifier and saying, okay, this whole thing is an object. Now, once I add this modifier, we're going to make an array of this whole object and duplicate it over to on the y-axis. So let's go ahead and do 10 of those. And you can probably see where this is going. Do another one, and we'll put 1.1 on the z, and there's 10 of those. So now you can see with this one object that we have, we've now made this whole cube of cubes. And also, if you go back into edit mode, right, I can edit this object specifically. You can see it edits all of these objects, right, because it's all based off of this one, because it's all coming from one object being arrayed on the x, y, and z. So that's pretty cool. Now, one thing I'll do to just demonstrate a point is I'll add a subdivision surface modifier to the spheres. So if this was an in-person workshop, I would ask, what do you think is computationally most efficient? Having the subdivision surface modifier here or here? And the answer is, having it having it at the end is not good. I mean, it's fine. Your computer is plenty powerful; it can handle it, right? But what it's doing is it's copying the meshes all the way up, and then it's, if I turn this modifier off, it's getting this object here, and then it's doing all the computation to smooth this out and change the visuals, right? If you were to just put it here at the top, it would, if you take all the arrays away, it would make this first and then start, putting it in the array. And that way you don't have to actually compute everything each time. So that's just one kind of thing about the array stack. And then we'll get away from the arrays so I can demonstrate the next one. The next modifier that I use occasionally is the Boolean modifier. So let's say I have a cube and I want to, like, I don't know, cut a sphere, like half of a sphere into the cube so that, like, it looks like there's an ice cream scoop taken out of it or something, who knows, right? That would be a really difficult thing to model. So instead of doing that, what we can do is, first I'm going to subdivide the sphere a little bit so that we have a better resolution for it. And you can see we now have a lot more vertices and it's a lot smoother. And I'm then going to add a Boolean modifier to this cube. Now it's important we do it to the cube and not the sphere, because you add the modifier to whatever you want to be the thing you want to get cut, right? So we want to cut the sphere out of the cube, so we add the modifier to the cube. And you can see with this Boolean modifier we have an option for an object here, and if we hit sphere, you can see, you can kind of see, it's hard to see until you apply it and move the sphere out of the way, but you can see that it's actually going to cut out this area here. So it's much easier if I just show you. So if I were to just to hide this sphere with H, right, it acts like it's still there, right, even though we can't see it. It just makes sure we don't render the sphere. But I can move this around, make it a little more shallow. And by the way, Alt H is the thing to bring it back. But let's say I want to move this here, here, here. Then I can go ahead and apply this. And then once I take this away, you can see we've actually made this mesh, and it has this very complicated shape cut out of it that would be pretty much impossible to actually model, right? So that's something really cool that if you watched my first workshop about the modeling in the car, um, that's a really useful tool to like, if you have the car chassis and you need to make a wheel well for the car, instead of modeling that, you can just put a cylinder in and then cut that out of the car and make the wheel well. Okay, so next we have two more. Just gonna make a cube again. We're going to talk about the mirror modifier. This is a really, really nice one to have whenever you're modeling any kind of complex object. Um, it's really nice when you're modeling a complex object. It doesn't have to be complex, um, but usually with a simple object you can just make it quickly and you don't need a mirror modifier. But so what this is doing is we've added the modifier, but it doesn't look any different, right? And if we move it around, it doesn't look any different. Now, if we go into edit mode and maybe move around the face here, you can kind of see what's happening, right? This is our object right here. We can't actually select this thing, right? This is our object, but we've mirrored it on the X. So I find this a little bit confusing because we're not actually mirroring it over the X, we're mirroring it over the Y, but I guess it's just saying we're mirroring it in the X direction. Um, but you'll get used to it. Um, Now it's important to note that like, sorry, if we take this face and we do this, it's like, that's not good practice because we're now having a bunch of intersections happening, and it's not going to be good topology. So, especially one thing that people get mixed up on is if they have a cube and add a mirror modifier, they're like, well, it didn't do anything. And it's like, yes, it did. It's just the other half of your cube is clipping through each other, right? Like there's two of them there, but they're just on top of each other. So whenever you do a mirror modifier, you want to take one of your faces and set it to be at the center, right? So you don't have any clipping going on. And then I can go ahead, let's just give this some more resolution. I can go ahead and like, I don't know, make some interesting changes to my model. And you can see it's being replicated over here. And then the cool thing about the mirror modifier is that, you know, when we apply it, when we hit apply on the mirror modifier, there's going to be two vertices here, right? Because it's going to copy this vertice, reflect it over the y-axis, but it's on x equals 0, so it's going to be at the same spot. Well, the mirror modifier will actually just take this whole loop, right? All of these that are on x equals 0, and it'll just merge them together to be one vertice. So you don't have any duplicate vertices there. So you can see if we go into object mode and we hit apply, then you can see go back into edit mode, and this is now one vertice, right? You can even search up, or actually you can hit M and merge by distance, and this will take anything that's like super close together, any vertices that are like super close together by a threshold, and merge them together. And it says here that we merged 0 vertices, right? If it hadn't already merged them in the mirror, then we'd have vertices that we merged because they were too close to each other, but it already merged them when we applied the mirror. So that's really helpful. Yeah. So that's the mirror. If we control Z back, so we haven't done this. Um, let's say that I want to move this over here. Well, I can mirror it on the y-axis too. If I move this up on the Z, then we can mirror it on the z-axis, right? And the reason that I moved it up on the Z and over on the Y is so that it wasn't clipping into itself. Um, so now we have this complex shape that's been mirrored, and we edit this, and it edits both sides, and all four sections or whatnot. So mirror modifier is very, very nice, very helpful, especially when you're doing any kind of modeling for like if you're making a character, um, or like an enemy or something like a physical, you know, humanoid thing, then you want that to be symmetrical on both sides. So, it's always helpful to have a mirror modifier there. Okay. Last modifier is the decimate modifier. Um, and to do this, I'm going to add a sphere here. And we'll do like that. Apply, subdivide here, give it some fractal randomness, not too much. Right, so this is like a really weird looking random sphere. And if we go ahead and use our decimate modifier, this is a very interesting modifier. So it does nothing because our ratio is at 1, right? And what this will do is it will try to collapse certain, it'll make it lower resolution, right? So it'll try to collapse certain faces and combine them with other faces. But you're obviously going to lose detail here. So as soon as we start moving this ratio down, you can see that, you know, it actually gives us the amount of faces that we have on this object right now. You can see, the faces are going way down, but obviously we're losing a lot of resolution here. So, you can go super far down. And this is a really good modifier if you wanted to make something like a low poly-esque kind of thing with a specific style. Decimate is really good for that. And there's also a triangulate option that will um, take any kind of four-sided face and just make it a triangle. Um, Usually, it's a good idea of something that you do um, to keep your topology nice and make sure that nothing clips through each other. But yeah, like I said, this is a tool that I use often because I make a lot of low poly games. So like if you're making a low poly tree, then you can add a lot of variation with like this random part of proportional editing. Um, so actually, I can show you just a very brief example of that. If I subdivide, oh, turn this fractal, subdivide with the fractal of 0, right? So it's just simple subdivision, and turn on proportional editing, which we actually I didn't cover this in my first video. So proportional editing is really nice because when you turn it on, it lets you edit stuff in proportion in like a certain range. It's got a fall off. You can edit the fall off with your mouse wheel. It shows you um, up here what the proportional size is. Um, so it's very nice. And you can also change your fall off up here. So I covered this in the first non-recorded workshop, but not in the video. So if I choose the random fall off, right, then it's going to give me a lot of, random variation. And maybe I even add a subdivision to that, right, and apply that. And this looks okay, but it looks very like a grid because it started from a grid. But I can go ahead and add a decimate modifier, take this down a bit, and now you have a much more low poly feel. Maybe this is like a mountain range, who knows? I can add some color to that later. But yeah, so that's the decimate modifier, and that covers all the modifiers um, that I wanted to go through. I guess again, it's important to remember the modifier stack and how everything um, is stacked up from top to bottom, and how the Blender goes through and does the top one first, and then the second, and the third one. It keeps going down. Um, so you can do a lot of cool things with your modifiers, making abstract art. Yeah, they're just really cool to use. Okay, let me take a drink of water. Okay, so now that we have covered modifiers, that was a big chunk of what I wanted to do today. The next thing we can go into is UVs and texturing. So let's say that I have, um, let's do a cylinder. Actually, I'm going to add a cylinder and just make this a higher resolution here. Let's just go 96. Okay, so I have my cylinder here, and it's pretty high resolution. And I am going to grab a browser window and, I don't know, get a texture, right? Get a brick texture, seamless. So let's say I wanted to take this brick texture. Let's see, just gotta make sure it's seamless. Yeah, this is a seamless texture. Okay, take that. I'm just gonna save it as brick, and then if I wanted to apply that texture to this model, I would have to go through materials. So let's go ahead and make a new material. I covered this in my last lectures as well, but I'm just going to name this material brick. And we're going to go into the shading. Nope, not the shading, sorry. Where is it? Maybe there's nothing set up for this. But we're going to then split our window vertically. You can do that by right-clicking on one of the sidebars, like this black sidebar or this top one, doesn't really matter. And you can, splitting it vertically, makes two side by side, and splitting it horizontally would make, one on top of the other. And you can go ahead and click join, and um, you can point arrows. And when you point an arrow up, it's going to say it's going to collapse the window on top. So, this is the window we get. So just to show you that one more time, if I had like, I don't know, a UV editor here, I want to join, let's join down this time, collapses this window into that one. Okay, so I'm going to open up a shader editor here, and this is the more advanced materials editor. So this is a pretty good preview of just like what you can do with materials, but it gets a lot more complicated, and we'll go into this um, in a second. So to add our image, you can see this is a node-based system, by the way. So this is a bunch of nodes that you can add to make different materials. And N will toggle a menu here. I usually just have it off. So anyone that was wondering, my screencast keys is down here now. So what we want to do is we want to take a texture, and Shift A is the hotkey. Just like it's Shift A to add stuff in this viewport, Shift A adds nodes in this viewport as well. And there's a whole lot of options here. Blender has some really good material. It's a really good material maker. Remember, they use this to make, photorealistic, scenes, and people use this to render architecture and stuff like that. So it's a very professional program with a lot of good material options. But we're going to add a texture here. It's actually already a brick texture, but I'm going to use the one that I got from my image. So there's an image texture right here. And open an image, get my brick, and you can see once we do this, it does nothing because we have to go into material preview because solid does not show you the materials. So Z material preview, and that will show you your brick texture. Okay, so it looks great. We've applied our brick texture, and there's a lot of different options we can mess with here. This stuff has to do with your image options. Can it repeat? Where does it repeat? Interpolation, stuff like that. And then this is a lot more complicated that we won't go into that. But you'll notice, it works pretty well around the outside here. But what if I didn't want it to be like this for the top? No idea why. Um, Actually, I'm gonna see if I can find like a barrel texture that we can actually use. Yeah, here we go. Okay, I'm gonna save this as barrel. Actually, no, we're gonna use this one. This is better because it has tops and bottoms. Let me just grab this real quick. about you? There we go. This works. We're going to save this as barrel.png. Okay, so I'm going to X out of that one and open desktop barrel.png. So here, obviously this is not what we want, right? It's not at all what we want because what this is doing is it's taking a flat image and it's mapping it onto an object that's obviously not flat. So we have to tell it where we want each part of it to be, where we want the faces to be on the image. And the way to do that is with a concept called UVs. So we're going to go ahead and change this viewport to a UV editor, and we're going to go into edit mode on this object. Now we can zoom out and we see it's already pulled up barrel.png for us. And if we go into edit mode and select everything, you can see exactly how it has unwrapped these non-flat surfaces onto a flat image, right? So if we go into faces, click on this face, you can see, it's mapped this face to be right here. So what we can actually do is, let's go ahead, go to face select. There we go. Go to face select on here, and we can now actually change this around. And you can see on this version of the object, we can change how and where this face is mapped to on the image. So I'm going to do my best. It's a little weird. We have like a lopsided circle here. But I'm going to do my best to align this circle to the top of the barrel. And I'm actually just going to go a little bit smaller than it should be, just so I can get rid of any white on the outside. Awesome. And actually that's the bottom. We want the top. There we go. Now I'm going to do the same thing with this face. I move this over here, scale it down. It's important to note here that the y-axis is this way, the x-axis is this way, because this is a 2D projection, right? There's no z-axis. So scaling on the y is like this, scaling on the x is like that. So I'm just going to line this up as best I can. And you can see here we now have a nice top and a nice bottom, but our side is still messed up. So if we go ahead and select all the sides with an Alt select, remember Alt select, you can select all the sides in a ring. You can see exactly where they are. So I'm going to hit A to select all of those. And then I'm going to scale them down and put them here. And again, just try to match them up as best as I can. Now, if we select everything over here, it'll show us everything, all the faces mapped onto the image. And, it actually looks pretty good. It's just kind of what we want. Now, this is obviously, it's not a high resolution model at all. You can clearly see that there's like, stuff that's like we would obviously want some actual physical rings around here that we can raise just to make it look better. This is just obviously just a sphere, um, but for just a sphere, it actually looks pretty good. And we've gotten rid of all this white space in the image. We've successfully mapped exactly where we want each face on the image or on the model to correspond to on the image. So yeah, so this is pretty good. Now, usually, if you're using any kind of image texture, you will have to do this method. But if you're using any kind of just flat material, it's just a color maybe, um, or if your whole image, like the brick, if your whole image is a brick, is a brick texture, and you don't care where the face is mapped to, then you don't have to do this. But oftentimes you will care because it will have to match some certain parts of the image, like the top or the bottom or the sides or whatnot. Okay, so that's a pretty good introduction to UV editing, and it's especially important when you're exporting to a game engine. I'm not sure about Unity. I don't use Unity very often, but when you're exporting specifically to Unreal, you have to make sure to unwrap your objects. So if you're in edit mode and you hit A to select everything, and then U is UV mapping, you can pick any of these options. Now, we're not going to do that now because we've already done that manually, right? But if I were to just smart UV project, you can see it kind of tries to do it on its own. But obviously, it didn't get it right because it doesn't know where the image is. So we're just going to Control Z. But if you don't do that, it's going to make a lot of the lighting on your object. It's going to be really weird when you import it into a game engine. So you have to remember to unwrap your UVs on every object you export, at least to Unreal. Not sure how Unity handles that. So this process that we just did here of applying a texture to an object, that is, called texturing. And next thing we're going to do is we're going to go through some more advanced material stuff. Now, usually, you won't do your materials, if you're making a game asset at least, you won't really do your materials in Blender. Um, you'll do them in your game engine. So most times it's not even worth, if I'm making an object that I want to export into a game engine, I don't even bother to make the materials in Blender. I just go ahead and make the materials in Unreal. But however, it's important to note that like, let's say I do this and get a ring here. And this ring I don't want to be the brick texture, and I want it to be, I don't know, just a gray. And that's not going to make sense in the context of the model. But if I wanted it to just be gray, right, like this, I would have to separate the materials and assign the faces to the materials before I exported. Um, like if I exported without assigning these faces here to this gray material with this assign button, then it wouldn't recognize that these are supposed to be a different material in the game engine. So, but I'm just going to put this back. I'm just going to Control Z a bunch of stuff until we are back to where we were. Okay. But in this case, we only have one material, so there's no point in assigning anything to be different because by default it's this brick material, which I'm going to rename to barrel. Okay, so what if we wanted this to look, I don't know, a bit more realistic, right? Um, so what we can do, I'm not sure how well it's going to work with this material. Usually when you want to make very realistic models, you would separate these things into different materials. So you'd have one wood material, you'd have one steel material, right? And you'd have, I guess, material for this cap or whatever. Um, but I'm just going to show you some concepts of how you can make pretty realistic looking materials in Blender. Again, if you're planning on doing this in a game engine, just go straight to the game engine and learn about how you do materials in whatever game engine you're using. Um, because if you spend a whole lot of time making a material here, only to try to export it into Unreal, it's not going to come with you. So there's not a good reason to do that in here. But let's say we were making something really cool in Blender that we wanted to render out as an image, and it has no intention of being in a game, and we just wanted to make it a cool image. So we're going to go back to the shader editor, and I'm actually going to go ahead and change my view to rendered view. And it got very dark, so we have to go and add a light. So in object mode, we're going to add a sun, and by default, the sun points straight down, but I can change this to point in a direction, and I have that, and I'm going to also click these buttons to turn off any kind of, gizmos or grid or world axes, just so I have a clean view of what the material looks like. And then I'm also going to add a point light, which is just a light at a point, right? And I'm just going to put this right up here and make it pretty powerful. And that'll help us see the changes that we make later on. Okay, so if we go back to if we select our barrel object, we can see a lot of options here. So this is our base texture, and we can collapse this for now. We're not really going to be editing that because that's just the image that we want to use for our coloring. But we have a lot of options here. So In my last video, I talked about how for a specifically tuned style of shading, think like Breath of the Wild or stuff like that. Um, think so we want stuff not to really be able to reflect off of it. So if we take our roughness down to 0, right? If you think about the actual physics of what's happening, something with that's very smooth, but it's not at all rough is like a mirror, right? So it's pretty much reflecting all light, and you can see, it's reflecting a lot of light from this close-up point light. If we take our roughness to 1, it's barely going to reflect any light at all. Specular is kind of the same thing. Specular is just general reflection. So you can see how it all gets brighter as we increase the specular, and you can make it more metallic or less metallic. But we'll keep that at 0 for now. There's a lot of other stuff you can do. You can make like complex materials, like wax. So like a wax material, or maybe like a see-through plastic material, is really complex actually, because not only do you have this first base layer of what's on the outside of the wax, but there's also light that the actual light rays can penetrate through the wax a little bit. So, you can see light on the edges because the light will go through the little bit of wax and still reach your eye. So you can do a lot of subsurface stuff with waxes, and if you want to make like cool candles, you can do that. But we're not going to be going into anything that complicated today. You can also do like emission shaders, good for like sci-fi stuff. So if we go ahead and add an emission shader, and um, by the way, middle click and drag is how you get around this area. If we put the emission shader into the output instead of this stuff, so this stuff is here, but it's not doing anything right now. And we can change the color here, and now this acts like a light source, right? It's almost as if, think like Tron, right? We have Tron-like lights, um, and that's like the surface of this is just the direct light. But instead, we're gonna go back to this. But I use that for a lot of any kind of like sci-fi material that I want to make. It's very nice. So what we're gonna do right now is we're going to do some math with our materials, and we're going to add a bump map and a normal map. So a normal map is really helpful for determining reflections. So let's see. Let me pull up a normal map here. So this is what normal maps usually look like, um, and you know I'm actually just gonna download this one real quick. It's not gonna make sense with our barrel, but normal. I'm just going to demonstrate the normal map and a bump map on a plane. Um, let's see. So if I add these back in, hide this real quick, and add a plane, and also just subdivide this a couple times to give it resolution. I'm going to make a new material, m.plane, just something random, and then turn these back off again. Okay, so now we have this plane material, and let's see. We want an image texture here, and we're going to open up our normal. Okay, now we're also going to change, or we're gonna put this into normal here, and something really interesting just happened. Um, we didn't actually add anything to the color, right? The color is no different, but we changed where the light can be reflected off of, right? So if I were to say, make this like a, I don't know, gray cobblestone-ish color, you know, you can see specifically in these reflections, like with the how shiny the material is on the surface, on the white parts of this normal map, which we can bring up our normal map here, right? So normal maps use a really special color theme, um, but on these purple higher parts, we can see it's letting us do a lot of reflection, and it's very shiny there. But on these greenish and red, lower parts that are supposed to be like crevices, there's no reflection, and that's actually why they look black. So if we also let's go back to the shader editor, and let's go ahead and put this, or sorry, we have to add a node, which I don't know where this is. I'm just going to search it for bump. I think it's like, yeah, vector bump, but you can just search any material or any node you want. Um, so what we can do here is we can take this in the normal and add that there. So actually, I apologize. The normal here is for bump maps. For a normal map, you have to put this into like roughness, I believe. Yeah. So now we have the shiny in the dark. I believe that's correct. Yeah. There we go. So yeah, you can really see it there. It's very shiny on certain parts, other parts not so shiny. Um, Really good for smudges and all that. But the bump map is what gives you the more like the physical crevices and stuff like that. So let's go ahead and add the bump to the normal map. And now you can see, without actually having any complicated mesh, we've made it look like this is some really complicated high resolution something, right? Like this looks really, really good. And if we turn our gizmos back on, it's still just a plane, right? There's nothing crazy going on here. It's just a plane. So this is like a really, really common technique that um, game developers will use to make something look more realistic. Um, if you want to go into making game assets or becoming a game developer, um, you pretty much need to know how to do this. And it's gonna be different based on what software you're using. If you're not using Blender, it's not gonna look like this. But the concept is the same, right? You have your bump map, which gives you these nice crevices and you know, kind of it changes how much light is reflected based on where the crevices should be, based on the image that you've used. And then the roughness map, or the specular um, normal map, is more fine-tuned reflections. It gives mainly these, um, this stuff here. And then you can even go one step further here. I'm not sure how well this will work, but we can try it. If we subdivide this a bunch to actually give it a lot of resolution, we can add a modifier to this. We can add a displacement modifier using a texture. So if we go ahead and add a texture here, um, we can add an image texture, and we can use our normal map here as our image texture. Now, obviously, so what this is doing is it's taking our plane mesh, and it's important to note that we have to add a lot of resolution. If we don't have a lot of resolution, it's not going to work very well. Um, but it's taking what we have of our resolution and adjusting each vertice based on this picture, right? So darker vertices are going to be lower, higher vertices are going to be higher. Um, this isn't the best image to use. You can see there's a lot of variation here, but we can change the strength of this. And now we have, we go to like, maybe we go to like 0.03. It's like, okay, well now we actually have a really realistic looking mesh here. And we've gotten that extra little bit of realism because we've actually added resolution. So now it's a more complicated mesh. But as a result of that, we actually can get this physical displacement from a modifier here and make this look really, really nice. So a lot of times, like I said, games will use displacement modifiers like this because at the end of the day, you know, if you have an asset that needs to be super detailed, like an asset that's like, I don't know, if you're going to inspect it really heavily in your game, um, then adding a bunch of vertices like this isn't the end of the world. Um, and using a lot of these bump maps and normal maps are used everywhere. A good example of this is in Overwatch, which is a Blizzard game. There's a lot of stairs in certain places, not everywhere, but a lot of stairs that aren't actually stairs. They're just ramps. and the ramps have these normal maps and reflection maps and bump maps on them to make them look realistic, to make them look like stairs, when in reality they're just ramps, right? So this is really helpful for any kind of like physics that's going on because physics on a flat ramp is way easier than physics on actual stairs. So it's much better to have it, to have the user think they're on stairs, but not actually be on stairs. So it saves a lot of, I mean, it saves a lot of computational power because you don't actually have to render out a physical complex object that is a stair with a bunch of vertices. You just have to render out a plane that is a ramp. So it's really, a lot of this stuff is really interesting. You can go into a lot of shading and dive down the rabbit hole there. And the last thing that I wanted to cover here is that you can do a lot of edits on your materials here. So like, let's get rid of this bump map, get rid of this roughness, and just make this, excuse me, the base color, and also get rid of this. So now we just have an image projected onto a plane. All right. Now you can do a lot of interesting things with these nodes here. One of my favorites is that you can do color stuff. You can adjust hue and saturation, invert stuff. You can do just actual color curves if you do like Photoshop and you know what that is. Um, you can do a lot of convert stuff. So let me just take this in here and take saturation down to 0 to make this just a black and white image, right? Um, Now, those of you that know anything about computer graphical programming is you know that pixels have a value from 0 to 255. So what we can do if we want to is we can go ahead and like clamp this value. So um, in this case, I believe it's using 0 to 1. But if we take this down, we can clamp the value to, like I said, it's using 0 to 1 instead of 0 to 255. Um, doesn't look very good, but you get the point. We can clamp out all of the higher values, which are the brighter colors. Um, and, maybe we wanted just the crevices for our bump map, right? Well, then we can clamp out some values and get just the crevices and not these small details, put that into the normal, and now we have an interesting looking bump map. You'd have to play with a lot of different settings here, but you get the idea. Let's see. And you can also do, where is it? Can do a lot of math. There we go. So like I said, it's got values from, you know, 0 to 255, or in this case 0 to 1. Well, I can do a lot of math with that. I can do any of these operations on each pixel individually. Um, and it's ends up being really useful for more complex materials. Yeah, I mean, if you go into game development and really want to make any materials in at least Unreal, which also uses a node-based system. Not sure how it's done in Unity, um, but any kind of math with materials is really important. So I don't have an example of what. Actually, let's try a sign. Hold on. If we just like, yeah, okay, well, sign's not doing much. Let's see. So this is gonna square everything. Um, I don't know, kind of interesting. You can take like, yeah, you can just do a bunch of different stuff like square root. So it becomes really helpful tools when you want to make complex materials. So as far as like introduction to Blender for game design stuff, that's pretty much all that I have. There's a lot more that you can do in Blender, um, but even this last part about materials is something that you're not really gonna need. You're not really gonna need um, unless, I mean, you should just learn the material system for whatever engine you want to learn. But you shouldn't really use the material stuff in Blender because it doesn't transfer over. But as far as modeling stuff, I might do some more episodes on like sculpting and that kind of thing, or rigging an animation. I'll probably do one on that. But as far as just modeling basic static, non-moving things, that you want to put in your scene that are fairly simple objects. Like, that's it. It's not that difficult. A lot of it just becomes how much practice you get, and um, obviously making more things is going to make you better at making those things. So trust me, when I started out modeling stuff, I would spend a lot of time making the simplest objects because it just wouldn't look right. But nowadays I can just do it really fast, and I'm practicing on my more advanced stuff in my animation and that kind of thing. Um, so yeah, that's pretty much all I have. If you guys have any questions, I'm assuming you're in the UMD Game Dev Club, so you can shoot me a Discord message. But that is all from me until I see you for the next episode, whatever that might be.